Hi, welcome to the Retirement Railroad Matinee Modeling Tip of the Day. I'm Steve, and today we're going to talk about some track modifications, layout, and progress in general. But more importantly, modifying the layout, putting in a crossover with Smales. And I talked about it previously about how the advantages are to electrofrog switches, and in particular these new old stock Pico switches I got. We talked about that already, but we're going to go into it in a little more detail and a specific application on the layout. All right, back here, this is Fairview Avenue of Downers Grove, and back over here the Aurora Engine servicing facility, both outside Chicago in the western suburbs, circa 1965-ish. Okay. And I've got to the point here where we're kind of wrapping it up, for now at least, as far as the scenic portion of it. Detail work's yet to come. I mean, I have all kinds of stuff to do on the lumber yard. I still have Fairview Avenue Station to put in there. But I'm waiting on some flats from PTF Design to put back here. And I got some other stuff I got to do over here. Plus I have this area down here coming out of the north end of Union Station. I'm thinking maybe an interlocking tower right in this general area. Perhaps a nice little road across coming off scene. And then some other scenic details. I've got some fascia work that I can do as well, which I have to do before I can actually use the plaster on over here. So anyway, so we're just going to switch away from this area back over to this area of the layout, which is the farm scene and the Aurora Engine servicing facility with the roundhouse and turntable. Okay, but this area back here, working around the installation, working around my desk was a challenge, and you know, it works, but it's not right. Okay, so I want to make some changes to it before I get into doing the turntable and roundhouse over here. I want to get the track correct. Coming out of north end of Union Station, I really need a crossover. I think in a previous one I called it a double crossover. It's not, it's a single crossover. So let's swing the camera down. We'll take a look at it again. Right down in this area. All right, and these two Pico switches. I've pre-cut some wire, and I use thermostat control wiring, and I think it's 18 gauge wire that I will be soldering on to the Smales, and wiring up the electrofrogs. Now I've got these all cut, ready, and stripped, wire stripped, and ready to go. And I have pre-drilled the holes for the switch throw wire to come up here and here, and two holes here and here for the electrofrog connection wire. Okay, so those are all done, and what we'll do is we will actually get the wire soldered on, get these built. There's a throw mechanism that's got to be done, and it comes with this little pack of stuff with some piano wire, set screws, and then an adjustment bar. And the adjustment bar goes in this groove, and it adjusts the tension of the throw, or the length of the throw on the switch. And I learned the hard way. Start with it at very low tension, because it's easier to increase tension than it is to release tension, because you're from the upside you're pushing down to increase tension. To decrease, you got to try to pull it up, and it's not easy once it's installed. Okay, so this comes with a thin gauge piano wire. These Smales. I go ahead and buy some 0.05 or 0.07. I can't remember which. It's not that big a difference. Piano wire. Okay, and that's what I'll use, and I'll bend them to the same specifications as the Smales call for as well. Then what I will do is I'll save this piano wire, and I've got a bunch of it already, and I'll use it to make the fencing post for chain link fence. Okay, because it's thinner, easier to work with for chain link fence, particularly that top rail. All right, so that's what we're going to do. Stay tuned. We'll get these things wired up and set up first so that we can mount everything else. Okay, so first thing we want to do on this, or the next thing I should say that we want to do on this project, is get these males ready. And here's the thin piano wire that comes with it versus the thicker piano wire that I use. You can see the difference there. Alright, so I need 2 of those, so I simply take and cut off 2 sections. Now notice I'm not using side cuts, alright, or dikes is the other word, wire cutters is another word. I'm using these heavy duty cutter pliers, same type or style that steel workers use to cut baling wire to tie steel. So because the cutting edge is much thicker and it'll go through this, whereas using some side cuts, you will hurt those blades. You'll put indentations in them, and then they're no good for what you're going to use them for. All right. So I simply want to cut off 2 of these. And the instructions come with a template that you can use for determining how to bend these. I've done over 40 so far, so I know how to bend them already. But you simply can use the template that comes with them as well. First thing you want to do is just a small 90-degree bend here at the end. All right. And what that is for is to go down in to the Smale. All right. The next thing is a very slight, about an inch, you can look at the directions, but a very slight inward bend. Okay, so you end up with something that looks like that. All right. Now the next thing you have to do, because you're using thicker piano wire, the hole in the Smale, there's 2 holes in this throw mechanism. One is for the set screw, the other is for the wire. All right, but this the hole for the wire is not big enough for our bigger wire. So using a pin vise, call them a hand drill if you will. But pin vise is it's the same thing. All right. So I just need. I may have too big of a bit. No, I got the right bit in there. Huh. But we just have to drill out that hole. You know, don't be overly hurried, and whatever you do, be careful. Alright, because if you drill through this thing too fast and you go all the way in, there's a circuit board right behind there. Okay? And the last thing you need to do is have this drill bit screw up the internal circuit board. Right. And remember, we only need the amount of that little throw. I'm about halfway there. Okay. So next thing is we need one of these brackets. Last time I did one of these boxes, I had screws go flying everywhere. How many mile railroaders does it take to open up a bag? Okay, so this, if the further you put it down, the more tension there's going to be to throw the switch. Alright, these motors are strong and they will screw up your switches if you're not careful. So start up there, then it's easy to go down through the hole to push it further down. All right. Now this hole is big enough to get the rod through. There's no problem there. All right. And then it simply goes in the hole we just drilled. Push that in. We take one of the screws that comes with it. Again, how many mile railroaders does it take to open a pouch? Obviously one more than what's here. Well, I need another one of these out anyway, so for the motor. Now, the way this is going to work is this will get mounted underneath here. All right. And that's a 5/8 inch hole, by the way. And the rod goes through the hole on the throw bar. Now on Pico switches, you have to take the little spring that is right in there. You have to take that out. And it's not a coil spring, it's just a lever spring. And all you really got to do is grab a hold of it and pull it out. All right. Then this goes down over that rod, through the hole over the rod. And there we go. Okay. Just like that. Then as the motor gets actuated, it will throw it one way or the other. Okay? put the set screw on. And all the set screw does is it keeps that rod from coming out of that throw bar. Okay, just like that. Let me get the other one done, then we'll solder up some wires. Stay tuned. We'll be right back. Okay, so I've got my wires fed through on the solder pads. Alright, and it's numbered over here. We'll start over here. 1 through 8. White is 1, red is 8. In the previous tip of the day, or 2 previous tips of the day, whatever, I talked about these pads and what they're used for. The white, and granted, you can use any colors you want, but for this, I'm going to refer to them by the colors I use. Okay? The white and the red, all right, are for the power to run this switch activator. Okay, make it go back and forth. Okay, now I have a separate bus line for all of my switches, so the white and the red will connect to that bus. All right. Now there's 2 internal double throw, double pole switches. Okay, one is controlled by blue and black and brown. The other by green, orange, and yellow. Okay, the blue and the black are the feed from the track, not the switch bus, but the track bus line. Okay, one to each rail of the track. Again, I have that on a bus line. The brown, okay, goes to the electrofrog underneath here. Okay, right there. Gets soldered to that. Now I pulled this brown wire out of this control cable so that I can run it separately, because it's only going to run from here to here underneath. Okay, the rest go down out to the bus line. Now the same holds true for the green and orange. Okay, you can use that doing the same thing, all right, that feeds the yellow. Okay, that could be for light, signal lights as an example. Okay. So we're going to be using, although I solder them all up because I may want to do light signal lights later, I am going to use the black and the brown, black, blue, brown for this electrofrog. Okay, the red and the white to run the switch. Okay. On the other end, I have already stripped out the blue, the black, the white, and the red. I left the others unstripped so they don't short out. The brown is already pre-stripped as well, although I'll be cutting the brown line much shorter. So that's the wiring again, okay, on the Smail. Now I just have to solder it up and get it mounted. Stay tuned. Okay, so got the first one all soldered up, ready to go. Now some people have an aversion to soldering, and hopefully you saw how easy it was for me. You put a little bit of flux on each of the pads and wires, put a little solder on the gun, tap it on there, it melts into place, you're good to go. The key is having a good soldering iron. This is a variable temperature, and I have it set at 800 degrees. That's the temperature I like to solder at. Works fine. For those that still have an aversion to soldering, Circuitron, the manufacturer of Smails and tortoises, they have versions with terminal blocks. Okay, and you put the wire in, screw, clamp down on it. I have never had a problem with ones that I've soldered. I cannot say the same for the terminal block versions. Inevitably, I've had some that the screws didn't stay tight over time, and they pulled out on me. Luckily, the only place that's happened is under here and under an area over there, both of which I had access to. Okay, so anytime I have one of these embedded in foam, it gets soldered. If you buy the ones that don't have the terminal blocks, you can buy the terminal blocks separately and then solder them on. Okay, or you can buy the ones that are pre-soldered on. The part number from Circuitron for a Smale is 6200. A 6-pack of them is 6206. 12-pack is 6212. And if you put a T after those numbers, that means it's the terminal block version. So if you're shopping eBay, you know what to look for. Okay. Hang tight. Let me get the other one soldered up. Okay, so we got them both soldered up. Because they're DCC chip enabled, we got to give them an address. Okay, and I have an addressing scheme for my whole layout, and with the main lines, which are these two tracks here. All right, the outer main line is odd numbers. The inner main line is even numbers. But since these two are both, it's a crossover, we want them to throw at the same time. Okay? If one is going straight, the other one needs to be going straight. If one is crossing over, the other one needs to be crossing over. So to do that, we're going to give them the same address. Okay? And the address, because of what I have previously, the address for these is going to be address number 7. So to program these, I have my alligator clips, my leads, powered up to the red and the white, the 2 motor control power. All right, and then the other end of the alligator clips are hooked up to my test track to the appropriate rail, which would be the same. You could hook it up to the track bus, but I have a separate bus for my motors. It just helps isolate problems, but you can hook them up to the track rails too. So that's what I'm going to do for right now to get them programmed. To program it, they have to have power for it's either 3 or 5 seconds, and it has already had that. There's a button under here, and I'll show you on the other one. Okay. There's a button there. Okay. You simply press that button, and it'll start to flash. See it flashing there? All right. Now you just take your controller and I want it to be turn 7, so I go and address 7, throw, and there it goes. Okay? Then you have to take power away from it. All right? Eliminate the power. Now the address is set. Okay? To test that theory, and you should always test it, by the way. Hook it back up. And throw it again. There it goes. See it through. Alright, it's programmed. That's all there is to programming a Smail. Alright. Now, time to program the other one. It's also a good idea not to put your alligator clips where they're shorting out your rails. Alright, so this one's programmed. Move it out of the way. Now we'll program the other one. And it's the same thing again. And like I said, we want to address it, give it the same address so they both throw at the same command or close at the same command. Gotta give it its 5 seconds. Alright, we can hit the button. And it's flashing. And it's still flashing. Okay. And that's all it takes. And again, we want to check it. Alright, so now to mount them on to our wood. Now, that template comes with the instructions. And this is just pre-printed onto like cardstock that I can cut out, etc. But in this case, I really don't need that template because I can get to where the switch itself is, and I simply need to mark where the holes are going to be. Drill my pilot holes. Now, if you're working underneath some bench work, the template comes in handy. You can put it up there, mark it off, drill 2 of the holes, right? Put some screws in, and I use these 18/8, 3/8 inch, number 4. I use these. Okay, they come in varying lengths, but this is the length I use. And if you put 2 in first, then you can slide the snail or tortoise in to those grooves, tighten it down, and it'll hold it in place while you do the other 2. I'll show you what I mean here in a second. Okay, so I got the 2 screws started, and the holes are grooved. They're not holes, they're slots more or less. Alright, so I get it in there, set it. Now I can add the other 2. Maybe. And doing this underneath benchwork is not an easy task. I'll tell you that right now. Started. Different screwdriver. Things are always easier when you use the right tools for the job. Trying to make do with the wrong tool just to save time will cost you more time than what it would have taken to go get the right tool. And if you're underneath bench work, it's still faster to get out from underneath the bench work, go get the right tool. Plus you'll save yourself a bunch of frustration. Okay? So, that's one end. Flip her around to the other side. And by the way, when I mark these, I'm putting the rod center of hole. But you got to center the throw on the machine too. Alright. Then mark your holes. And you want it, the machine itself to run in the direction of the switch. So, not of the outing, but of the straight section. If you have a Y, you want it to run down the center, as an example. Those of you that say pilot holes, I don't need no stinking pilot holes. It's a whole lot easier if you just go ahead and drill them. Okay, so I got that one, the electric fog wired up. I've got the switch through the throw rod. Now I still have this one to do. Now normally I would put a jumper from the outer rail to the inner rail on each side to help transfer that electricity, but Pico has little catches underneath, alright, that help the points make contact. So it's not just the switch points making contact with the outer rail. You've got that little jumper or tab hanging off there, okay, on each side. So I'm not going to put jumpers on these. So let's get this fed through. And it's rather easy. Don't forget to use the flux. And that way this wire makes contact with both of the very thin wires on the switch. Okay, simple to do. Feed our throw rod. There we go. And the only other thing is to put our insulated rail joiners. The insulated rail joiners. There we have it. Alright, now it's still loose. Still needs to be tacked down. But I'll wait until I have this entire strip mounted here. Okay? But in a previous tip of the day, I talked about the 4 insulated rail joiners. Because you have to have 4. Not just the 2 crossing over. But also these here, because they're connected to this frog. And that frog is going to change polarity. If you don't have this here, with the polarity change, it's going to short out, okay, with the other rail out here. So thus, you have 4 insulated rail joiners. Okay? And that gives you an idea of what it looks like. And the underside. Okay? Now, once it's all set and ready to go into service, I'll come back and I'll cut both of these throw rods. All right, but for now, that's the way we're going to leave it. Now, when I actually get around to mounting it in this section of the layout, it's going to be a challenge. Okay, because underneath there's a cabinet here and a desk here, and there's only about 2 inches of foam along here, and those hang down close to 4 inches. So once I get it cut away so that the plywood base fits even with the foam, I will have to mark where the switch machines are, right, and then cut in down much further to give the clearance necessary, all right, which may affect the front fascia of this cabinet right here and the desk back here. We'll play that one by ear, and in the grand scope of things, it's not going to be that visible anyway. Okay, so simple follow-up on mounting and wiring Smale switch machines for electrofrogs. That's your tip of the day. I'm Steve, and thanks for watching. Bye now.